Welcome to the AWS Certified Cloud Practitioner Prepcast, where we guide you through everything you need to know for your certification exam. Whether you're just starting or looking to refine your knowledge, this course will set you up for success. Brought to you by baremetalcyber.com. Let's get started. In modern applications, data is often generated continuously. Clickstreams from websites, logs from servers, telemetry from IoT devices, or video feeds from cameras. Handling this kind of real-time flow requires services that can ingest, process, and deliver data quickly and reliably. Amazon Kinesis is AWS's managed suite of streaming services built for this purpose. Instead of waiting to batch and process data hours later, Kinesis lets you analyze and act on information within seconds. This makes it valuable for use cases like fraud detection, real-time analytics, live monitoring dashboards, and recommendation engines, where speed matters as much as accuracy. The heart of the suite is Kinesis Data Streams, KDS, which provides scalable streams of ordered data records. Data is ingested into the stream and then consumed by applications in near real time. The primary scaling unit of KDS is the shard. Each shard provides a fixed amount of read and write capacity, so as workloads grow, you add more shards to scale throughput. A single shard supports up to 1 megabyte per second of writes and 2 megabytes per second of reads. This makes shards a predictable building block. Performance grows linearly as you add more. Data flows into Kinesis via producers and out via consumers. Producers can use the Kinesis Producer Library, KPL, the AWS SDKs, or even simple HTTP APIs to write data into streams. On the consumer side, the Kinesis Client Library, KCL, provides robust support for distributing reads across multiple applications, checkpointing progress, and handling failover automatically. By relying on these libraries, developers avoid the complexities of coordinating multiple readers and can instead focus on processing the incoming data. Kinesis manages concurrency and balancing behind the scenes. For high-scale use cases, AWS offers Enhanced Fanout (EFO) for KDS. Normally, consumers share the 2 megabyte per second read throughput per shard. With EFO, each consumer receives its own dedicated throughput, allowing multiple applications to consume the same stream independently without bottlenecks. For example, one application might handle fraud detection, while another builds real-time analytics dashboards. Without EFO, both might compete for read bandwidth, but with it, each has its own lane. The trade-off is cost. EFO adds expense, so it should be enabled only where parallel consumption truly requires it. Kinesis Data Streams also provides retention windows for replaying or reprocessing data. By default, records are retained for 24 hours, but this can be extended up to 7 days or even 35 with extended retention. This allows teams to reprocess streams if downstream applications fail or if analytics pipelines need to be recalculated. Retention ensures that data is not lost in the face of errors and that teams can correct mistakes without requiring fresh ingestion from the source. It turns Kinesis into not just a real-time pipeline but also a buffer against operational hiccups. Data ordering is maintained through partition keys, which determine how records are distributed across shards. All records with the same key land in the same shard, preserving order. This is useful when processing clickstream events for the same user or telemetry from the same device. However, poor key design can lead to hot shards, where one shard becomes overloaded while others remain underutilized. Careful selection and distribution of partition keys is critical to achieving both balanced throughput and ordered processing where required. Firehose also supports data transformation by invoking AWS Lambda functions before delivery. For example, raw IoT sensor readings might be enriched with geolocation data or reformatted into JSON before being stored in S3. This inline transformation makes Firehose pipelines more powerful, reducing the need for additional ETL jobs downstream. It allows teams to shape data as it flows, ensuring that what lands in Redshift or OpenSearch is already analysis-ready. For teams needing to process data continuously as it streams, AWS offers Kinesis Data Analytics, built on Apache Flink. This service allows developers to write SQL queries or Flink applications that perform real-time transformations, aggregations, and anomaly detection on streaming data. For instance, Kinesis Data Analytics could calculate rolling averages of temperature readings across thousands of IoT devices or detect outliers in stock trading activity as it happens. By embedding analytics into the stream itself, it eliminates the latency of storing and reprocessing data later. Beyond text and log data, AWS also provides Kinesis video streams, designed for ingesting and storing video and audio data from connected devices. It supports both live playback and integration with machine learning frameworks for applications like facial recognition or motion detection. Video streams demonstrates Kinesis's breadth. It is not only for text records and logs, but also for the heavier, continuous data streams of media workloads. Security is integral to all Kinesis services. IAM policies control who can write to or read from streams. KMS integration encrypts data at rest, ensuring that sensitive logs or events remain protected. For organizations requiring private connectivity, Kinesis supports VPC endpoints, preventing data from traversing the public internet. Together, these controls ensure that streaming data pipelines meet compliance and security expectations, even when they are ingesting millions of events per second. Monitoring is equally important in streaming architectures. Kinesis exposes CloudWatch metrics that track shard utilization, incoming and outgoing records, throttling, and iterator health. Scaling alarms can notify administrators when shards are saturated, while iterator metrics ensure that consumers are keeping up with the stream. These insights provide visibility into whether pipelines are stable or falling behind, helping teams tune throughput and consumption strategies. Finally, cost in Kinesis depends on the specific service and configuration. Data streams charges per shard hour and per million put payloads. Enhanced fanout incurs additional costs per consumer. Firehose pricing is based on the volume of data ingested and delivered, with additional fees for transformations. Kinesis Data Analytics charges for the resources provisioned to run Flink applications. Awareness of these cost elements ensures that architectures are designed efficiently, using Firehose where managed delivery suffices and reserving EFO for workloads that require it. For more cyber-related content and books, please check out cyberauthor.me. Also, there are other prepcasts on cybersecurity and more at baremetalcyber.com. When evaluating Kinesis services, the first design choice is between streams, Firehose, and analytics. Kinesis Data Streams is the right fit when applications must process data directly in near real time with fine control over consumer logic. Firehose simplifies delivery into storage or analytics destinations, best when you want a managed pipeline with minimal custom code. Kinesis Data Analytics extends this ecosystem by enabling stream processing with SQL or Apache Flink, so you can derive insights as data arrives rather than after it is stored. Each service aligns to a phase of the pipeline: streams for ingest, Firehose for delivery, analytics for transformation. Capacity management in Kinesis streams can follow two models: on-demand streams or provisioned shards. Provisioned shards provide predictable cost and performance, requiring administrators to manually adjust shard count as traffic grows. On-demand streams scale automatically based on throughput, making them easier to manage but potentially more expensive at steady high volumes. For unpredictable workloads, on-demand offers peace of mind. For stable, heavy streams, provisioned shards provide better cost efficiency. Choosing the model comes down to whether you prefer operational simplicity or tighter cost control. As workloads evolve, you may need to reshard streams to handle throughput changes. Splitting shards increases capacity by dividing traffic into smaller partitions, while merging shards reduces cost when traffic decreases. Resharding is an essential practice in managing long-lived data streams, allowing pipelines to scale elastically without downtime. For example, A retail company might increase shards during holiday peaks and merge them back afterward. The process must be carefully coordinated to avoid data disruption, but it gives fine-grained control over stream economics and performance. Kinesis delivers records with at least once semantics, meaning consumers may see the same record multiple times. To handle this, consumers must be idempotent, processing duplicates without changing outcomes. For example, if a payment record is delivered twice, the downstream system must ensure it is not double-counted. This design principle applies across distributed streaming systems. Reliability favors multiple delivery over loss, but correctness must be enforced by consumers. Building idempotency into processing logic is a key responsibility of developers using Kinesis. The Kinesis Client Library, KCL, helps manage complexity by providing checkpointing. Consumers periodically record their progress in DynamoDB, ensuring that if a consumer fails, another can resume from the last checkpoint. This guarantees continuity and reduces reprocessing overhead. For example, a log analytics pipeline can resume at the exact offset where it left off after a node crash. Checkpointing ensures fault tolerance and enables scaling horizontally across multiple consumers without manual coordination. Firehose delivery streams provide their own tunable controls, such as buffer size and buffer interval. Data is batched before delivery to destinations like S3 or Redshift. Larger buffers reduce the number of writes and lower costs, but increase delivery latency. Smaller buffers increase timeliness, but can raise costs. Tuning buffer size and interval is therefore a balancing act between efficiency and freshness. For example, a compliance system requiring near real-time data might use smaller intervals, while a data lake ingesting logs could batch for efficiency. Schema evolution is another challenge in streaming pipelines. Over time, producers may add or remove fields, potentially breaking consumers. AWS offers the Glue Schema Registry, which integrates with Kinesis to enforce schemas and validate incoming records. This ensures producers and consumers remain compatible even as schemas evolve. For example, adding a new field to JSON events will be validated, and incompatible changes will be blocked. The Schema Registry brings governance to fast-moving data environments, reducing the risk of silent failures. Global architectures often require multi-region patterns and replay strategies. Streams can be replicated across regions for disaster recovery or low-latency access near users. Long retention windows allow replaying historical data into new consumers, enabling system rebuilds or reprocessing with updated logic. For example, after deploying a new fraud detection algorithm, teams can replay stored transactions to validate accuracy. These strategies turn streams into long-lived assets rather than transient pipelines, providing both resilience and analytical depth. Integrations are a strength of Kinesis. Streams can trigger Lambda functions for lightweight processing, while Firehose can deliver data directly into S3, Redshift, and OpenSearch service. Together, these integrations enable end-to-end architectures without complex glue code. A common pattern is streaming application logs into Kinesis streams, invoking Lambda for enrichment, and delivering enriched data into S3 through Firehose. This combination demonstrates how Kinesis acts as both the highway for data and the hub for downstream AWS analytics. Cost management is an ongoing consideration. Partition keys must be carefully distributed to avoid hot shards, which waste capacity. Enhanced fan-out should be enabled only when multiple consumers truly require independent throughput. Otherwise, shared consumer throughput is sufficient. Firehose should be used for delivery-only scenarios to avoid paying for unused shard capacity in streams. By aligning design choices with workload patterns, organizations can keep costs predictable while still delivering high performance. Troubleshooting in Kinesis often focuses on hot partitions and throttling. Hot shards occur when one partition key dominates traffic, overwhelming its shard. Throttling happens when producers exceed shard capacity, leading to retries and increased latency. Both issues can be diagnosed with CloudWatch metrics, such as write provisioned throughput exceeded or getRecords.iterator age milliseconds. Fixes include redistributing keys, increasing shard count, or enabling enhanced fan-out for overloaded consumers. Observability ensures that these bottlenecks are visible before they disrupt critical pipelines. Monitoring also includes measuring end-to-end latency and consumer lag. Iterator age metrics reveal whether consumers are keeping up with the stream, while delivery metrics in Firehose show how quickly data is landing in destinations. High lag signals that scaling or rebalancing is needed. For mission-critical applications like fraud detection, latency must be minimized. For batch-oriented data lakes, some lag is acceptable. Understanding these metrics allows teams to tune pipelines for both business needs and cost efficiency. Despite robust features, pitfalls remain common. Tiny records increase overhead and inflate costs because each PUT carries base costs regardless of payload size. Skewed partition keys overload single shards while others sit idle. Overbuffering in Firehose can delay data availability, frustrating users expecting near real-time feeds. These issues highlight the importance of workload-aware design. Streaming systems reward careful planning of partitioning, batching, and consumer logic, ensuring that architectures remain efficient and predictable. On exams, the key is to map use cases to the correct Kinesis service. If the scenario emphasizes building custom consumers with control over order and retention, Kinesis Data Streams is the answer. If it highlights simple delivery to storage or analytics systems with minimal code, Kinesis Firehose is correct. If it calls for real-time analytics or continuous transformations, Kinesis Data Analytics is in play. Video ingestion belongs to Kinesis Video Streams. These distinctions mirror real-world design. Each Kinesis service is optimized for a specific stage of the data pipeline. In summary, Kinesis provides the building blocks to ingest at speed, process data in motion, and land it in durable destinations. By combining streams, Firehose, analytics, and video streams, organizations can build pipelines that scale from milliseconds of latency to petabytes of throughput. The challenge is not whether Kinesis can handle the workload, but whether architects design the pipelines with the right service mix, partitioning strategy, and cost controls. Done well, Kinesis enables real-time decision-making that turns raw data into immediate business value. That concludes today's episode of the AWS Certified Cloud Practitioner Prepcast. Be sure to tune in for the next episode and visit us online at baremetalcyber.com or cyberauthor.me for more resources, including news, mailing lists, YouTube videos, podcasts, and much more.